Hello and welcome. Today I'm going to talk about one of the most mysterious and exciting topics in the world of science: quantum tunneling. It's like the scientific equivalent of a ghost passing through a wall. If you're ready, let's get started. So, what is quantum tunneling? It's the ability of very small particles to pass through a barrier, just like a ghost passing through a wall. Imagine you have a ball and you want to get it to the other side of a wall. According to classical physics, you need to throw the ball over the wall. But in quantum mechanics, things work differently. Quantum mechanics is a branch of physics that studies the behavior of atoms and subatomic particles. In this field, particles can behave both as waves and particles. This means that sometimes they act like a ball in a specific position, and other times they spread out like waves on a pond. This dual nature allows them to have a chance of passing through energy barriers. How does this work? Imagine you have a tennis ball. Normally, to get the ball to the other side of a wall, you need to throw it over the wall. But in quantum tunneling, the ball somehow passes through the wall. This phenomenon is explained by a mathematical formula called the Schrödinger equation. The Schrödinger equation uses a particle's wave function to predict where the particle might be and how it might move. Essentially, this equation helps us understand the probabilistic nature of particles' movements. Think of ghosts passing through walls. A ghost doesn't need energy to pass through the wall, but somehow ends up on the other side. Quantum tunneling works similarly. Particles can pass through an energy barrier even if they don't have enough energy to overcome it. It's like they magically tunnel through. To understand this better, let's look at some real-life applications. Our cell phones and computers work thanks to the principles of quantum tunneling. The transistors in these devices are tiny switches that control electricity, and they can switch on and off very quickly due to quantum tunneling. This makes our devices fast and efficient. Another example is the behavior of radioactive materials. Radioactive nuclei emit particles by passing through energy barriers. These particles tunnel through the barriers to escape the nucleus. This process is used in nuclear energy production and medical imaging technologies. Solar panels also take advantage of quantum tunneling principles. Sunlight moves electrons in the panel past energy barriers, creating an electric current. This allows us to efficiently use solar energy. Quantum tunneling is also found in biology. For instance, enzymes, which are biological catalysts that speed up chemical reactions, can use quantum tunneling to make these reactions happen more quickly and efficiently. This is crucial for understanding fundamental processes of life. Another fascinating application is in superconductivity. Superconductors can carry electric current without resistance at very low temperatures. These devices enable us to measure magnetic fields with high precision and are vital for scientific research. The scientific and philosophical implications of quantum tunneling are also intriguing. This phenomenon helps us understand how the universe works and shows us that there is a world beyond classical physics. It reveals that the universe is actually filled with probabilities and challenges us to ask big questions. So, what kind of big questions does it raise? For instance, is everything in the universe truly determined, or is it based on probabilities? Are we living in a deterministic universe, or are all events subject to quantum randomness? Do we have free will, or are our actions influenced by random quantum events? Quantum tunneling suggests that not everything can be explained by simple cause and effect. Quantum tunneling is a mysterious and fascinating aspect of nature. It overturns classical physics rules while forming the foundation of modern technology. Quantum tunneling continues to reveal the secrets of the universe and amaze scientists, promising to keep intriguing us in the future. Understanding quantum tunneling is essential for appreciating the technology we use every day. From our cell phones to our computers, many devices operate based on these principles. Knowing that quantum mechanics is behind such advancements is truly mind-blowing, isn't it? It's important to realize that quantum tunneling is not just a theoretical concept, but has practical applications in the real world. Even the internet we use daily is a result of these technologies. Fiber optic cables and other communication devices work faster and more efficiently thanks to quantum tunneling. To elaborate further, consider the transistors in computer processors. These tiny switches control the flow of electricity, and quantum tunneling allows them to switch on and off very quickly, making our computers and phones faster. Have you ever wondered how radioactive materials are used in medical imaging? PET scanners, positron emission tomography, for example, use radioactive isotopes to see inside the body. These isotopes pass through energy barriers via quantum tunneling, helping doctors diagnose diseases. This plays a crucial role in understanding fundamental life processes. In the future, quantum tunneling will likely be used in even more fields. Quantum computers, medical innovations, and even energy production could be revolutionized. Understanding quantum tunneling is preparing for the future. As we delve deeper into this topic, we realize how complex and fascinating the universe is. Each new discovery shows us how vast and full of mysteries the universe is. Science is a journey that keeps our curiosity alive and constantly pushes us forward. Finally, understanding complex topics like quantum tunneling requires patience and curiosity. When combined with patience and curiosity, science yields the best results.